Hi everyone, in this video we'll be looking at some matrices past paper questions. So we're going to look at this first question that's in front of us. This was from June 2015, number 11A. Now there were 4 parts, part 1, part 2, part 3 and part 4. So we're going to look at each one and see how easy these questions can come sometimes, right? Once you know the work from before, right? Alright, so number A, part 1. Calculate the matrix product AB, where A is this here. This is a 2 by 2 matrix. And then we have matrix B, also a 2 by 2 matrix, right? I think we are accustomed now multiplying a 2 by 2 matrix by a 2 by 2 matrix, right? So AB would be 1, 1, 2, 3, and then matrix B by 1, 2, 0, 1, right? So I'm just putting it up there so I'll have some space down here, right? A, B, remember it's row by column, right? So first row by the first column. So 1 times 1 plus, so 1 times the first number there plus 1 times the 0. And then first row, second column. So 1 times first number, 1 times 2 plus 1 times 1. So that was first row, first column, first row, second column. Now we're going to go at second row, first column. So again, 2 by, you see the numbers repeated, 1 plus 3 by 0. Again, you see how the numbers are repeated, right? That's a trick we learned earlier on. And then second row, second column. So 2 by 2 plus 3 by 1, right? And from here, we're just going to simplify, right? So AB is equal to 1 by 1 is 1 plus 1 by 0 is 0. Then 1 by 2 is 2 plus 1 by 1 is 1. 2 by 1, 2 plus 3 by 0 is 0. 2 by 2, 4 plus 1 is 3. So our final answer for AB, we get 1, 3, 2, 7. Right? Easy 2 marks to get. Now in part 2, they said, show that the matrix product of A and B is not commutative. That is, AB is not equal to BA. So we are showing that we already worked out what AB is in part 1. Now we need to work out BA and show that those two matrices are not equal to each other. Now, you need to remember what commutative is, because they could have left out this piece here, that AB is not equal to BA, right? When a product, two numbers or two matrices are commutative, that means that AB and then BA should be the same, right? Commutative means the order, right, for addition and multiplication doesn't matter. Alright, so besides that, let's just go and find BA. So BA, let's put matrix B first. So 1, 2, 0, 1. And then 1, 1, 2, 3. So here we want to show that this is not matrix, this matrix product. AB is not equal to BA, is not commutative, right? So same thing like above, row by column. So 1 by 1 plus 2 by 2. First row, first column, right? 1 by 1 plus 2 by 2. Now, first row, second column, 1 by 1 plus 2 by 3. And then 0 by 1 plus 1 by 2. And then second row, second column, 0 by 1 again. And then plus 1 by 3. And then we could do it right down here just to simplify. So 1 by 1 is 1 plus 2 by 2, 4. 1 across here, 1 by 1 is 1 plus 2 by 3 is 6. 0 by 1 is 0 plus 1 by 2 is 2. 0 by 1, 0 plus 3. So your final answer will be 5, 7, 2, 3. So therefore, you can just put a note that therefore AB is not equal to BA. Or you could also say A and B are not commutative, right? So you could just add in a line if you want to. So part 1 and 2, they tested the matrix multiplication, right? Alright, going on to part 3. we want to find the inverse of matrix A. So matrix A is 1, 1, 2, 3. Remember, first we need to find the determinant, right? Remember, the determinant is the product of the first diagonal, so 1 by 3. Take away product of the second diagonal, 1 by 2. So determinant of matrix A is 3 take away 2, which is simply 1, right? So A inverse, remember, it's 1 over the determinant, then by the new matrix. The new matrix consists of the first diagonal, the numbers switch. 3 comes here, 1 comes here. And the second diagonal, the numbers remain the same, but we change their sign. And that's it. And this is 1 over 1 on the outside, so you could just simply write 3 minus 2, 1, because 1 divided by 1 is just simply 1, right? And you don't need to write it. So that's part 3. And then part 4, given that matrix M is 2x, 2, 9, 3, calculate the values of x for which the determinant, remember there's another way to write determinant, right? So they told us the determinant of M is equal to 0. So again, they write the determinant as that, or we could write DET anyway, but you must know that this means determinant as well, right? So if the determinant is equal to 0, so let's work that out. So the determinant, remember, is the product of the first diagonal, so that's 2x times 3. Take away the product of the second diagonal by 9. And because it's equal to 0, we put it equal to 0. And now we're going to get an algebraic equation. We're just going to solve x. 2x times 3 is 6x. Take away 2 by 9 is 18 equals 0. So 6x is equal to, opposite of taking away 18 will be adding 18. I'm just going to come across here. So 6x is equal to 18, right? 6x is same as 6 times x equals 8. So x is 18 divided by 6, opposite of multiplying by 6 is division by 6. So x is, and that's the answer there, right? So this entire question was easy to get. It was 8 marks in total. It was easy to get the 8 marks, right? And they tested a little bit of each part. They didn't bring the simultaneous equation here though. Alright, y'all, we're looking at another question. This is May, June 2014. So, number 11a, matrix M is defined by, so matrix M is 7, 2, P, negative 1. They said determine the value of P for which a matrix does not have an inverse. Now, I would have mentioned this in my video, finding the inverse of a matrix. Now, if a matrix does not have an inverse, that means that that matrix is singular. So therefore, this means that matrix M is a singular matrix. And what is a singular matrix again? A singular matrix is when the determinant is equal to 0. So let's find the determinant. 7 by the product of the first diagonal, 7 by minus 1. Take away product of the second diagonal, so that's 2 by p. And all is equal to 0. So you're going to get minus 7 minus 2p equals 0. So then we're going to get minus p is equal to 0. Opposite of taking away 7 will be addition of 7. So you have minus 2p is equal to 7. So minus 2 times p equals 7. So p is equal to 7 over minus 2. Opposite of multiplying by minus 2, we take away minus division by minus 2, sorry. So P is 7 over minus 2. You can leave your answer as a fraction. And part B, they said express the equations, these are the equations, in the form AX plus B, where AX and B are matrices. Now, you read carefully, they said express the equations in the form AX equals B, not solve for X and Y. So this is all they wanted you to do. You have to pull out the first matrix, which is 4 minus 2, 2, 3. Remember, this is like simultaneous equations. So do your first step. Multiplied by xy, and that is equal to the two numbers at the end. And that is all they wanted, right? But they see they asked it in a different way. They didn't ask to solve x and y or anything. They just put it in the form ax equals b, right? Just something to look out for.